Okay, so Google has just dropped Gemma 4. And this is 4 new models with multimodality, thinking, function calling, the works. And honestly, that alone would get me covering this. But that's not even the interesting part. The interesting part is the license. Gemma 4 ships under an Apache 2 license, not a custom license with weird restrictions, with the whole sort of open weights but don't compete with us clauses. This is an actual real Apache 2 license, which means for the first time you can take Google's best open model, modify it, fine tune it, deploy it commercially, do whatever you want with it. No strings attached. And when we combine that with actually inside these models, we're talking about 128 expert MOE here, native audio, native vision, built-in reasoning. All of that becomes a pretty big deal. Okay, so let me give you a quick orientation because there are 4 models and the naming is a little bit confusing here. Gemma 4 comes in 2 tiers. You've got what they're calling your workstation models. So this is a 31 billion parameter dense model and a 26 billion parameter mixture of experts model with 4 billion parameters active. And then you've got your edge models. So this is the E2B and the E4B. Now, these are tiny, efficient models designed to run on phones, Raspberry Pis, Jetson Nanos, and really pretty much at the edge, anywhere you need a good quality model here. Now, I've covered the Gemma line of models since the original release. I covered Gemma 3 on the channel. And I know back then, while a lot of people were very impressed with it, they were kind of frustrated with some of the things around the license. So you had this capable model, but a license with enough restrictions that a lot of people went with Llama or went with Qwen instead. So the Apache 2.0 move here is Google basically saying, okay, fine, we'll play the same terms as some of the other open model providers out there. And in fact, as we're talking about this, some of the other model open providers in China are actually pulling back their latest releases and not making them open like they have in the past. So the other big thing up front here is that Google is saying that these are built from Gemini 3 research. So basically, the architecture innovations that went into some of their flagship commercial models are slowly now trickling down into the open weights models. So if you've been running local models, and I know a lot of you have, the landscape has kind of settled into this pattern. We've kind of gone past the Llama models. We've now got sort of Qwen, Mistral, and they're all sort of competing on benchmarks in this sort of fixed parameter range for dense models. But we've also seen, up until recently, most of these models were text only, or at best, text plus vision. If you want audio, you're kind of bolting on Whisper, you're bolting on some external ASR pipeline. And often if you wanted something like function calling, you're kind of hoping that the model cooperates with your prompt template. So what Gemma 4 is doing here is shipping all of that natively into a single model family: vision, audio, thinking, function calling. And all of these 4 are actually built in from the architecture level, not sort of bolted on after the fact. All right, so one of the key things that makes Gemma 4 better than the previous Gemma series is that it now has the ability to do sort of long chain of thought reasoning. And we've seen clearly that this can improve outputs and can get you better final answers, etc. Now, not only can this reason across text, but it can reason across different modalities. So it can reason across images if you want it to basically pass in an image and make use of that. And for the first time, you can actually reason across audio. So that is also cool in here. Obviously, this ability to do the long chain of thought has improved a lot of the benchmarks that are out there, and they're getting really strong results on the MMU Pro as well as SWE-Bench Pro. Along with the reasoning comes function calling. So anything you want to do that's agentic, you want to basically be using function calling and tools. So this has integrated a lot of the research they put into the function Gemma model, which they released at the end of last year. But now this is both in the small models and the bigger models. So a lot of people will think that this is not that new, but really the way people did this in the past for doing this kind of function calling was actually just having the model to be better at instruction following and then sort of coaxing it into it. Gemma 4 actually has the function calling baked into it from scratch. So this is sort of optimized for multi-turn agentic flows, allows you to do with multiple tools, and it really shows up in some of the agentic benchmarks and tasks that you can do. All right, I mentioned earlier in the reasoning that the two smaller models, unfortunately, not all four models, but the two smaller models actually have audio support. And that audio support is a lot better than what we had in Gemma 3N and some of the previous Gemma models that had audio support. This means that you can do things like ASR and transcription, but you can also do speech to translated text support. So I'll show you that when we go through the walkthrough. On top of this, the audio encoder is not only better, but it's just a lot smaller. So this helps a lot for anything that you want to do at the edge with these models that you're just not going to be using as much device storage and memory. Another thing of comparing Gemma 4 to, say, the Gemma 3N series is to do with the image encoder. The image encoder with those Gemma 3N models, while it was good, it really was a bit sort of old-fashioned in the way that they did it. It didn't handle things like aspect ratios well, and because of that, you would often see that it didn't do a great job for things like OCR, etc. The Gemma 4 models basically have native support for these interleaved multi-image inputs. My guess is from playing with it that it's probably had a decent amount of sort of OCR and document understanding training in there. And because you can do that sort of multi-image input, you can actually do video here and have reasoning across those multi-images. So generally just comparing the Gemma 4 against Gemma 3 and Gemma 3N, you've got a lot more updates in both with the smaller models supporting the audio and better multimodality support. And whereas Gemma 3N only had a context window of 32K, even for the small models on Gemma 4, they've got a context window of 128K and then 256K for the bigger models. All right, so let's talk about some of these architecture choices and the model sizes themselves. So the mixture of experts model is 26 billion total parameters, but only 3.8 billion are active at any time. Now, they haven't gone for a huge number of experts like we've seen some of the other models go for recently. They've got 128 of these sort of tiny experts, 8 being activated for each token, plus 1 sort of shared always on expert. So if we compare that to the Gemma 3 model, which the largest model was a 27 billion parameter dense model, obviously in that case, you are using all 27 billion at the same time. So roughly, this is giving you sort of the intelligence of a 27B model with the compute costs of something around a 4B model. Now, this you can certainly run on sort of consumer GPUs, and I'm sure that even as I'm recording this before it comes out, we will see this on Olama, on LLM Studio, etc. And Google themselves is also releasing the QAT checkpoints. That's the quantized aware training checkpoints, so that the quality of the model stays high even at the lower precision. Now, what if you don't want an MOE model? Well, the second model that they're releasing as part of their Workstation groups is a 31 billion parameter dense model. And this takes a different approach. This is fewer layers than Gemma 3, but with quite a number of meaningful architectural upgrades here. They've added in value normalization, and they've changed the attention mechanism to be something that's converging on really what works best for sort of long context. And speaking of long context, these Workstation models have a 256K context window out of the box, so that's pretty significant for a local model. The other cool thing is the vision encoder here. So they've moved away from what they were using in Gemma 3N to a vision encoder now that's got native aspect ratio processing. So you can feed in an image or a document or a screenshot, and the model handles the actual dimensions. So that's definitely going to be an interesting thing for how that plays out for things like document understanding, OCR, and tasks that are perhaps downstream that people want to be able to train for things like that. Okay, so for these Workstation models, Google is pitching these as being your local coding assistant, perhaps an IDE co-pilot, or even something you're going to run on a small server for multiple users. So this 31B does code generation, completion, correction. On top of that, we've got something that's fully multilingual with 140 languages for its pre-training and 35 languages for their post-training and the instruction fine-tuning. All right, now if we look at the edge models, we've got the E2B and the E4B. These are where it gets really interesting for a different reason. So these are the two models in the family that actually support audio. They've got a built-in ASR encoder that can be used for speech recognition, also for things like, the speech to translated text. So you can speak in one language and get text out in another language, all in the one model and on device. Now, interestingly, the audio encoder here has been massively compressed compared to the Gemma 3N model. It's 50% smaller, coming down from 681 million parameters down to 305 million parameters, which means that not only have you got a reduction in the number of parameters, just the disk space required for that is now way smaller, going down from 390 megabytes down to 87 megabytes. And interestingly, it seems that they've changed the frame duration here from 160 milliseconds down to 40 milliseconds, which means we should get something that's much more responsive for transcription. Now, they've kept some of the innovations from Gemma 3N, but it also seems architecturally that they've realized that perhaps some of those innovations that they had in 3N were not actually the best thing to go for. And my guess is that this is the Gemma team realizing that not everything carries over necessarily from research to production. All right, so the vision encoder on these small models is also dramatically smaller, right? So in the past, we were looking at vision coders around sort of 300, 350 million parameters. In these new models, we're down to 150 million parameters. And it's quite dramatically moved away from the way that they were doing that with those models down to this newer architecture, which is lighter and therefore quite a bit faster as well. So if you're building an on-device assistant, like an actual voice-first AI, where you don't want to send anything to the cloud, this is exactly the kind of thing that you want. You've got 128K, context window, vision, audio, function calling, the ability for the model to do thinking, all in a model small enough to run at the edge with extremely low latency. Okay, so just jumping in here, I'm going to be testing out the smallest model here just to show you some of the key things that it can do. Because I'm testing this before it's actually been released, I'm having to use a special version of the Transformers library, but I'm basically just downloading the weights for the smallest, the E2B version of Gemma 4 here. And you can see very quickly that if we want to use this for doing thinking, we basically just need to pass in on the chat template that we want to enable thinking, right? So we just put enable thinking equals true. We run this, we get our response back. And then we can just pass that response out. So you can see the question that I asked here was, what are some common use cases for deep learning in finance? And then we've got the answer coming out from this. If we want to get thinking off, all we need to do here is just put enable thinking equals false. And now I'm getting very similar answer actually in this case to what I had before, but there's no thinking. It's just gone straight to giving us the answer out. So you do have the ability to turn thinking on, thinking off for going through this. All right, next up is if we want to actually put an image into this, you can see I'm just basically loading up an image. And then we're just going to take the processor. So we've got the auto processor here, and we're going to just pass in an image into that. And you can see that we can actually just pass the image into that's what I'm doing here. We've just got the processor image token so that it will know to insert the image in here. And then later on, when we define the inputs, we pass in the text inputs, which is basically our messages processed through the apply chat template. And then we pass in the images. And in this case, it's just one image that we're passing in there. And you can see, sure enough, that we can go through this. I've actually only put out 128 tokens for the output here, but you can see that we asked it, this is the image of a girl on a beach with the dog. And I've asked it just what is going on in this image. And you can see that the image captures a warm, lovely moment between a person and a dog. Here's a breakdown of what's happening. We can see the subjects, we can see the interaction, and it's cut off before I've put the full setting and stuff like that in here. It's very good at images and also reasonably quick for this. This is one of the cool things. If we want to do audio, we basically do the same thing. So here I've just got an audio file. So I will just play that audio file so you can hear a bit of it.
Dancing in the masquerade, idle truth in plain sight jaded. Pop, roll, click, shot. Who will I be today or not?
But such a tide as moving seems asleep, too full for sound and foam. When
Okay, so you can hear it's actually two voices. And we can see that if we pass this in, we basically just pass it in the actual audio here, and then we've got text. And then we can, just run this through and process it. And sure enough, it will give us an output. Now, if we look at this, it's actually transcribing it pretty well in here. right? But you can see that it's caught both the woman's voice, but also the man's voice in here, very accurately with this. Now, would I necessarily use this instead of an ASR model? Probably not. But if you plan to use these in chain, like if you plan to have an ASR model then going into an LLM model, you can certainly do that here. Another really cool thing that you can do with the audio here is that you can do sort of like a translation. So here you can see we define a target language, in this case, Japanese. We define a source language, English. And we can just tell it, okay, transcribe the following speech segment in the source language, then translate it to the target language. And then we can tell it how we want it to format, etc., as it's going to do it. And sure enough, it does do this, right? It actually goes through, transcribes it in English, and then just gives us a Japanese translation out. Now, I've copied this into Google Translate, and it seems to be, roughly right for this. So don't forget, this is just the E2B model, right? This is a very small model. We could use the model that's bigger for this, and my guess is that that would probably do better at some of the multilingual things as well. So if you want to run the small models, you can run the small models on a T4. I'm actually just using a T4 GPU here. If you want to run the bigger models without any sort of quantization, you're going to need something with a decent amount of RAM. So you're looking at something sort of like an H100, the RTX 6000 Pro, that kind of thing. But overall, both the workstation models and these much smaller models are very impressive in their particular use cases here. All right, so the model is out on Hugging Face, but also on Google Cloud. So if you want to serve the bigger models, you can do that. One of the things that I think is really cool is that you can actually serve those two bigger models fully in a serverless way now with Cloud Run. So Cloud Run now has the ability to use a G4 GPU, which is actually an NVIDIA RTX Pro 6000. So you've got 96 gig of VRAM there, and you can actually load up the full-size versions and support those in a serverless way where it spins down to nothing. So I'll certainly look at that in the future going forward as well. So just to wrap up, there's 4 new versions of Gemma out. Both the base models and the instruction tune models of these are out. The base models here are going to really become interesting for doing things like fine tuning. I think I'll probably end up making some videos around doing that, both with the small models, but also with the bigger ones, to show how when you've got actually a very strong base model, like the Gemma models have always had, you can really benefit from doing your own fine tuning for particular use cases, etc. Now, I don't think that this is the full family of Gemma 4 models. I think we'll probably see more over the next few months or so, but certainly this is a really good start to actually start using these models and testing them out for your particular use cases. So anyway, as always, let me know in the comments what you think. If there's something particular you want me to show with these models going forward, whether that's like in the past, I did some Gemma RAG videos. So maybe we can look at doing some updates to those. And like I said, I'll almost certainly do some different fine-tuning videos with these to show what they can actually do. So if you're interested in that stuff, make sure you click like and subscribe, and I will talk to you in the next video. Bye for now.